Hi, everybody. We'll be starting the presentation now shortly. Okay, we'll get this thing kicked off. So my name is Jane Eustace. I'm an industrial hygienist, and today we're going to be talking a little bit about fall protection, and specifically, we're going to try to apply the hierarchy of controls for fall protection in some unique ways, just to kind of give you guys a bit of an overview of how we can choose safer methods, really, when we're working at height. I'm going to obviously offer quite a lot of examples as we go along. But generally speaking, we're looking at, using elimination first and kind of working our way down towards things like using actual fall arrest systems. So that's pretty much a little quick overview of what we're going to be talking about today. For those of you who have never attended one of our webinars before, I do have a couple of just housekeeping slides to cover off here. So Workplace NL is the name of the organization from which I work, and this is effectively the no fault workers' compensation system that we have here in the province. So at the moment, we're serving about 215,000 injured and ill workers and 18,000 employers. And in addition to the compensation element that we certainly do provide, we also promote health and safety in workplaces and provide information around things like return to work. The learning series really is a initiative that we have here at Workplace NL. The purpose of it really is to deliver useful, beneficial education around different occupational health and safety topics that are of importance here in the province. We do have a we have a strategic injury priority team here within my organization that deals with falls. Falls are a big source of accidents here in the province and also contribute a lot to the fatalities and whatnot that we have as well. So within that learning series, we've got a variety of webinars that we do around various topics. And again, falls is just sort of one of those strategic priorities that we try to do some education around. And by we, I mean prevention services, which is really the department that deals with all things non-compensation. So we're primarily a group of advisors, health and safety professionals who do, again, various different things, including education, like what we're doing here today. We also help employers with high claim costs to try to get their injuries down. We provide people with statistics and we develop resources for them. We also have a variety of training standards that we do, including the 2-day fall protection course. That's a training standard that we kind of have. We assist committees and, again, just in general, kind of provide advice around occupational health and safety issues. As it relates to this presentation that we're going to be having today, the presentation will be about an hour and a half. I encourage anyone who's in attendance to ask questions. You can do that through the chat window. So if you look at the little kind of box that popped up when you signed in to this webinar earlier, you'll notice there's a couple of gray tabs, and down towards the end of it is a window that says chat. That is the best place to put any questions you have or any other concerns as we're going along. And what I'll do is I've got a coworker behind the scenes who will kind of compile all those questions for me at the end, and we'll review them then at the end. I also want to just make you aware that just above the chat window, we have another little tab that's called handouts. And in that particular area is where you can find a copy of this presentation if you'd like to have a PDF version of it. If for some reason you can't download it, or if you have questions that you don't want to discuss in this particular venue, I'll also put up my contact information so you can reach out to me if, again, you need a copy of the PowerPoint or if you have any other questions that you'd like addressed. We will take 2 short breaks throughout this presentation at the 30 and 60-minute mark. We call these micro breaks because they really are that, a very short little break. The purpose of these really is just to kind of give you an opportunity to get away from your desk for a second, get the blood flowing a little bit, let your back kind of reset a bit. I will take you through a quick stretch because I do find Even for my own purposes, it's nice during this type of work for me to get up and have a little stretch myself. I do want to just let you know now that if there's any reason why you can't participate in the stretch, medical or what have you, certainly you don't have to. Again, really what we're trying to get out of these little micro breaks, if nothing else, is just get people up and moving around a little bit, break up your day sort of thing. I think I've covered off all the housekeeping, so we'll carry on. I do want to highlight that November is Fall Prevention Month. Fall Prevention Month is a campaign in Canada that encourages organizations and individuals to coordinate different types of fall protection efforts to try to reduce the number of falls that we're having. Now, this particular effort is not solely occupational. This is also a public health effort, and certainly falls are a bigger, grander issue when we kind of think about outside of workplaces. Again, our focus here at Workplace NL is more on the occupational aspects of this. And this webinar that we're going to be doing today is actually part of our Fall Prevention Month series. So there's a variety of webinars that will be going on this month around falls and falls prevention. If anyone is interested in kind of checking out what else that we have offering, what else we are offering this month around falls, you can certainly check that out on our website. And at the end of the PowerPoint, I also have a quick little slide there that kind of shows you how to get to that link. So for today, we've got a fairly kind of simple, I guess, organization to this PowerPoint. I'm going to do a little introduction around fall protection, where we're just going to discuss some basic things. You know, what is fall protection, some definitions. Obviously, there's some different nuance to this, whether you're federal or provincially regulated. But really the guts of this is going to be on how to apply the hierarchy of controls to fall hazards. And again, it's that choosing the safer options first, and again we'll talk about sort of what those are, and like moving towards fall arrest as a PPE option sort of towards the end, where other options are not sufficient or not practical to put in place. So I'm going to try to really give you a lot of examples of kind of situations where people are sort of thinking outside the box as far as how to apply these rules. So we'll kick this off again just by talking a bit of general information around what fall protection is. So it is really a generic term. It's meant to cover off everything under the sun that could protect a worker who has the potential to fall. So certainly this is not exclusive to working at height. This would also include types of protection from slips, trips, and falls. And to kind of put it in perspective, we certainly have a lot more slips, trips, and falls. So what I mean by that is falls to the same level with when compared to falls from height. But generally speaking, the falls from height often result in a much more severe injury. So there's kind of a bit of nuance there. But we're going to, again, be talking about it from kind of all avenues, not specifically just talking about working at height. So within the province, so what I mean by that is any provincially regulated workers or workplaces, working at height is defined as working over 3 meters, which is about 10 feet or greater. In addition to that, and I know most people have that 10-foot rule kind of in place, there are a couple of other things as well to consider. If you're working above a surface or thing that if you fell onto it, it could injure you, in theory, you would also need fall arrest regardless of the height. So again, these are oars. If you can see they're within the little bracket there at the end. So you could have a situation, for example, where a worker is working directly over, say, an operating piece of equipment. They may not be 10 feet above said piece of equipment, but again, in the event that they fell, you know, they would be falling into that equipment, and again, could result in serious injury. And then similarly, that also applies if you're working above an open tank, pit, or vat that contains a hazardous material. And I would argue that 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 would also include everything up to and including water, because there's always the potential, certainly if you fell in somewhere that you could potentially drown. So anytime you're working above something that is potentially dangerous, if you were to fall on it or in it, that also needs to be considered as well. With the federal crowd, there's a slightly different definition. I know this sometimes makes things a little bit confusing, but say, for example, if you are working with a construction group and you're hired by a federal client to do some work on their site, at that point, you're kind of falling under the federal jurisdiction. So it's very important that employers are familiar with both definitions. So they don't use 10 feet, they actually use 8. And I would like to just kind of, for just conversation purposes here, mention that, these height ranges vary a lot from jurisdiction to jurisdiction. Even in the US, they use different heights to determine when someone is actually working at height. But again, it's important to know which ones apply to you. So for example, in the US, they use 4 for industrial and 6 for construction. That's kind of their general rule of thumb. And there's lots of individual workplaces out there that have also put in best practices. So a best practice is above and beyond what's legislated, what's required under the law. There are several companies I can think of that use 6 feet, and I actually know of one that at one point, at least, I'm not sure if they still are, but they actually use the 4-foot rule. So moving right along. So again, for the federal definition, they use 8 feet to the nearest safe level, or if there's a potential for you to fall into operating machinery, again, very similar to the provincial definition, or if you could fall onto a surface or thing that could cause you to be injured by contacting it. And this is kind of maybe the trickiest one of all. If a worker is working from a temporary structure, so that could be a ladder, a scaffold, that is more than 20 feet above the next safe level. Sorry, a temporary structure such as a scaffold, then they need to, or if they're working from a ladder at a height of more than 8 feet. Sorry, I apologize for that, a bit confusing there. So again, there's some nuance to the rules depending on what jurisdiction you're working under. So when we think about the hierarchy of controls, and we talk about this a lot in our webinars, there's sort of a process that you want to use when you're trying to figure out how to deal with a hazard. There's a movement from what is the most effective to what is really the least effective. And that's a bit different for falls. Typically, we'll see, elimination, substitution at the top, sure. Then we'll see our engineering controls, which are typically changes to the workplace. Then we've got administrative controls, which you'll see is at the bottom here. Those are basically things like procedures that would require a worker to do something. And then at the bottom, we've got our PPE options. However, with the hierarchy for falls, it's a little bit different because really most of our PPE is not used exclusively. It's not used outside of a system that's very critical to the function of that PPE. So the engineering and the PPE controls are kind of bundled up together, and that's really where we get into these passive and active controls. So passive controls are engineering type controls, like things like a guardrail system, that don't require any kind of really participation of any kind from the employee. They don't need to be trained. They don't need to do anything. The active controls, on the other hand, are more complex. They are a combination of engineering, PPE, and administrative controls. They really are a full system of controls. And it's very important that the workers that are using these systems participate and actually follow procedures to use these systems properly. And then at the bottom, we have pure administrative controls where there is no PPE component, there's no engineering component, it's just a procedural aspect, and that's it. So again, it looks a bit different with falls, but this is generally speaking how these types of controls would be laid out. So obviously there's a lot of pros and cons associated with some of the options that we're going to go over today. I really, again, tried to do my best to kind of think outside the box and think about situations that I've been involved with in my career, where, you know, an employer has really come up with a different way to try to reduce the risk of falls. Again, whether it's to same surface or working at height. I do want to just kind of highlight here, though, obviously there's a lot of real world elements involved here where some of the things we might be talking about just aren't practical. So it's something to keep in mind. But again, the idea with the hierarchy is to start with the most effective and work your way down in that order to make sure that you're not passing over an option that's potentially safer. So again, we're going to get into some different controls here. I'm going to start with elimination and substitution. So elimination is always the best option. It is effectively removing that hazard altogether. So there may be some scenarios where you don't really need to work, say, at height, or you may be able to reduce the amount of work that's being done at height. You might be able to reduce the height or reduce the number of workers that are working at height. Again, there's some kind of different options available there as far as elimination is concerned. But typically, in order to achieve something like this, it requires some careful planning, specifically when you're designing the project. Let's just say this could be a construction project, as well as when you actually start doing things like construction. So this is the best option. Again, it requires a bit of planning to make sure that, you know, these things are thought of up front. And in addition to things like construction, which I will focus a little bit on, you know, the building of structures and whatnot, elimination can also be applied to regular maintenance activities. I like to talk about these a little bit because, again, I think they add a little bit of a different spin on fall protection. But, you know, we use fall protection in all kinds of situations where we're not necessarily, you know, building a house or building a roof. But there can still be issues with, again, working at height or simply working in areas where there's, again, issues with slips and trips. So we're going to talk about, again, some examples as we go. Advantages of following this kind of hierarchy and maybe looking at things like elimination first. I just, again, like to throw these out at you guys for consideration. There is some potential savings if you can avoid working at height, for example. You can, you know, certainly save on the cost of purchasing or renting work stages, things like scaffolding, ladders, personal fall arrest equipment, AWPs, or aerial work platforms as they're called. You know, these things all cost money. So again, if there's ways to pre-plan so that you don't need these items to finish your project, certainly there's a cost savings there. There's also major potential reductions in administrative overhead. Again, depending on the specific situation, aerial work platforms, scaffolding, and personal fall arrest, all these things require training and preventative maintenance, which can be expensive. Again, depending on if you own or rent, there can be some variation there. But, you know, lifts need regular maintenance. Occasionally they get damaged and they need to be repaired. Scaffolding can be very expensive to rent. It can also be very expensive to purchase it. And again, you need qualified people setting that stuff up, dismantling it, modifying it, etc. There's, you know, requirements to check it daily and these sorts of things. Certainly, in addition to all these things, the idea of trying to do stuff to reduce work at height in particular can have a big impact on your safety culture at your workplace, especially if you're transparent with your efforts to try to, again, find a better way to do a thing. And certainly, if you can eliminate these fall hazards, there is a potential to reduce injuries that might occur in the event that someone did slip, trip, or fall. So again, I want to give you guys some examples. I try to get some local stuff because certainly, you know, when I'm talking about showing a picture of, say, you know, somebody doing something in another country, it maybe doesn't hit home as hard. There has been a bit of an increase in people building stuff on the ground rather than building it in place. So I got a little picture here of a roof in Charlottetown, New Brunswick, that was built on ground level to reduce the need to use fall protection and things of that nature. And then at a later point, once this roof was constructed, a crane was brought in to lift this roof into place, and you know that it would have been attached. This actually was used for a hotel project up in the Lab City area. Actually could have been an apartment building rather than a hotel. They did the exact same thing. They had a crew come in and build the roof on the ground, and then they used a crane to lift that roof in place. And I think hurricane clips or something involved there to keep it secured. So again, there's some practicality here. Obviously, in a real world condition, there may be some issues with weather and whether or not you have an actual area to lay down a roof next to the remainder of the project, where you very well could be building, you know, a large home or building to go along with this roof. But this is something to consider. These are the kinds of things we're going to be, again, talking about here today. More of a maybe a newer option is the idea of using modular systems. I personally was pretty impressed with the fact that we had a new modular building actually get added to our downtown area in the last few years, and that's kind of the picture there I got on the right. Basically, what's involved with this is when a large building is being constructed, all the individual rooms and other zones within the space are constructed in small sections on ground level, so in these little cubes or rectangles. And then once the individual sections are done, and a lot of them are completely done, I mean, interiors and the works are completed, all the individual sections get stacked on top of each other, again, using a crane to reduce the amount of need of workers to work at height. Now, don't get me wrong, there's still some work at height with the modular systems. Obviously, you know, you've got to make sure that these systems are, these individual modules are tied together. But this is, again, a reasonable way to reduce the amount of actual work that you've got going on at height. Maybe a few kind of simpler options if we want to, again, get away from construction. Does that rooftop equipment really need to be on the roof? A lot of building owners, their only issues with working at height in particular is their roof. And traditionally speaking, most businesses would say like a flat roof design are going to have quite a lot of equipment up there. A lot of that is space savings. You know, these are pieces of equipment that may only require maintenance, say, every 6 months or once a year. So the idea of kind of tucking them up in a way, kind of where they're less sightly, like where, you know, for the aesthetic of the building, saves a bit of space, I guess, you know, certainly, again, if rather than having it down on the ground. But when we think about the amount of effort then that has to go into maintaining these rooftop pieces of equipment, especially if they're within 6 feet of the edge of the roof, which is kind of our rule of thumb with regards to the roofing industry. It requires, again, a lot more administrative overhead, because then you're getting into situations where, you know, the person has the potential to fall off the roof, and perhaps you have to have a guardrail system, perhaps you're going to use personal fall arrest. But, you know, if we can just take that rooftop equipment and move it to ground level, we no longer have to get up on that roof, and that certainly might be of a benefit to some situations. Again, a bit of a newer piece of technology, but there is a lot more people using drones these days. And in particular, drones are a very useful set of second set of eyes, you know, that you can take and you can, you know, send out to areas, perhaps areas at height where you might need to do things like inspections. There was quite a lot of drone usage actually during the Hebron project and some other large scale industrial projects. And At this point, I believe there are several companies in Newfoundland and Labrador that offer drone services where they can effectively, again, get up at height and take pictures and videos and different things. So again, it's a potential way to avoid having workers have to access these areas at height for things like inspections, which again, sometimes it's, it's not truly necessary for that worker to get up there to do that. Even simpler example, and these have been around for a while, but if you've got stuff at height that you do regularly, is there a way to avoid using ladders and perhaps using some type of reach system instead? So there's a bunch of different types of systems out there that you can use for reaching high places. Some of them are specifically designed for things like changing light bulbs, which really is a big deal. I know I had a client years ago, they rebuilt their facility and they put all their lights along this one side wall, this one particular wall, kind of on either side. And it just so happened that that wall was on a staircase on both sides. So you're picturing a square box, and on either side there's a staircase going up, and all their lights ran along that wall with the stairs. So because the lights were so high and because of the steps, they couldn't set up a ladder. They realized kind of too late after the building was designed that they were looking really at bringing in scaffolding whenever they needed to change a light bulb in this scenario. But this type of a reach system would have done the trick for them, and they again would have avoided all that additional cost of bringing in equipment, and also again made it much safer for their staff. And then the picture on the right is actually a window washing operation. So we've got this big telescopic pole that comes out and washes your windows, and these are pretty handy little things. I actually have a tree trimming pole that I use quite a bit that has this telescopic aspect, so I can trim my own trees, without having to get a ladder or get out hire a bucket truck or something of that nature. So again, there's lots of options there. I came across a couple of things too around window cleaning that I thought I'd just share, because washing windows is, certainly somewhat of a high risk job considering what you get out of it, which is just a slightly cleaner view. There are some newer types of windows that you can get that flip inside out. These are more so geared towards residential homes, but I certainly would love to see them in commercial buildings where typically we'll see somebody on something like a swing stage or some other kind of suspended platform where they're doing their work. But again, if you could just kind of flip the window, you could do all the cleaning of both the inside and outside from indoors. And then on the left-hand side is this kind of, again, new little item I found. Some of you guys may be familiar with this. I think this was kind of on TikTok and some of these other social media places. But it's a type of cleaning device that has magnets on it that effectively cleans the inside and the outside of your window at the same time. So assuming your window can open so that you can kind of access the exterior portion, you can use this to kind of wash both front and back at the same time. So again, there's kind of new little pieces of equipment, different little things that come about. Again, don't get me wrong, in some cases, these things have to be designed into the plan of the structure that you're putting together. But in other cases, if you're willing to think a little bit outside the box, you can come up with ways to do stuff even after the fact. And then finally, and this was kind of a more of an industrial one, but this has come up a bunch actually for me over the years. Workers who have to get up at height to access valves and different kinds of things, to turn off and on, say, a particular piece of equipment, or perhaps, a line that's carrying water or air or some other kind of product that they're producing. If these valves have to be accessed often very unregularly, so maybe like once a year or once in the blue moon. But if they do ever have to be potentially accessed, especially if they have any element with regards to an emergency, like say if you had a leak, you can get these chains that chain valves that can be replace the normal valve head, and this allows workers to operate the valve from the ground rather than having to again get a ladder or a scaffold out to try to get up there and access that particular piece. So before we move on, I think we're going to take our first little micro break. So again, if nothing else, we just kind of want to encourage you to get up, move around a bit, give your back a chance to kind of lengthen a little bit. And I'm going to take you through, again, a quick little stretch. And the whole purpose of this stretch is to kind of get some extra height in our bodies and kind of stretch out the upper back and shoulders. So I'm just going to get you to interlace your fingers together, real easy. And we're just going to slowly reach up overhead. Try to kind of continue to look forward with this one. And we're just going to see how high we can get. Hold it for a couple of seconds, and then we're going to see if we can get a little bit higher again. So we're holding. Let's just see if we can get just a tiny bit more reach. And a lot of us usually can. And now we're just going to slowly bring our hands down to our sides, do a couple of shoulder rolls, just to kind of loosen that area up a bit. Bit of a wiggle maybe. And we're going to just carry on from there. Okay, so the next option for us is substitution. So this is the idea of replacing the type of work that you're doing or a particular tool or something like that with something that's just a little bit of a safer option. So when you can't avoid working at height or some other type of slip, trip, fall hazard can't be avoided, is there a safer way to do it? And again, a lot of the time you're looking at reducing the height or reducing the number of workers who are exposed, or you may simply just be choosing a safer device to allow you to do that work. So again, let's look at some examples here. So ladders are a big issue in a lot of workplaces, and there is a lot of different kinds of ladders out there when we think about, say, portable ladders versus a fixed ladder, something that's kind of attached permanently to a building. Generally speaking, the fixed ladders are a little bit more safe in a sense because they don't require the worker to set them up. And in some cases, a permanent ladder system can also have a lot of add-ons that add some extra safety that you wouldn't necessarily get from a portable, say, extension ladder. Again, there's a lot of, if practical, kind of elements to this. You know, there's different you know, factors again that would apply, but generally speaking, you know, if you can use a fixed ladder that has, say, a ladder cage like the picture on the left, or a ladder safety system like the one in the middle with the rail, you know, this might be a little bit safer than a portable ladder. And then on the far right hand side, I've just got a picture of a fixed ladder that leads up to a flat roof, and it's got this really nice little guardrail that kind of comes off the ladder and goes in that 6 feet that I mentioned earlier, which is kind of important for the roofing legislation, that allows workers to get up on the roof and then have a safe path to access that inner area, again inside that 6 foot from the edge realm, where they don't necessarily need to have any kind of PPE on, so there's no need for fall arrest or fall restraint, which we're going to talk about later. If you do need to use some kind of ladder or scaffold or what have you, why not try, instead of a regular traditional ladder, a portable platform? And I've seen a lot of these in use in industrial sites, in particular in garages where they're dealing with heavy equipment. These are pretty common to see. So these little setups have a set of stairs typically that leads to a platform that has a little rail or something across it, so the worker can, you know, walk up the steps, put the rail across, and then they're now on a secure platform where, again, they don't need to use any kind of fall protection equipment or anything like that. The guardrail is effectively what's protecting them from falling at that height. Again, there's practical elements to this. These portable platform systems take up a lot more space than a portable ladder. That's one issue. But they do come in a lot of different designs and variety, and you can get these for multiple workers, and sometimes that's what you need. Obviously with a ladder, you know, it's one worker at a time, but if you need a few hands up doing a thing at height, these portable systems can be quite handy to have. So there's no need, you know, for things like 3-point contact or worrying about balance, like overreaching the side rails and things of that nature. These things are all kind of not an issue if you've got a portable platform instead of a ladder. If a portable platform doesn't work for you, why not try a scaffold? Scaffolds, you know, if they're properly laid out, they may include some ladder components, but again, they provide that work platform with guard railing that again makes it such that the worker again doesn't need to worry about balance or 3-point contact. Again, they can be used with multiple workers, so there's kind of a lot of benefits to avoiding using a ladder and using another system. But generally speaking, you know, your scaffolding and your rolling platforms are going to be a little bit more expensive. So these are practical things to think about. But again, in some scenarios, this is just an easier way to go. Now, if a ladder, a scaffold, or some other type of staging is not practical in your work, why not try an AWP? So again, a ladder requires a lot of participation from the worker with the 3-point contact, maintaining balance within the rails. Most of these things are not needed if you're on a AWP, an aerial work platform. Again, we've got that benefit of perhaps having 2 people, depending on the nature of the AWP. You've got your guard railing there. Again, there's additional cost, sure, for the rental or purchasing of this type of device, but again, there's some benefits there as well as far as reducing the risk. And then again, I wanted to just kind of flip this to the more of the maintenance realm a little bit again. There has been a lot of improvements in the light bulb in recent years. I would hazard to say someone's probably going to write a book about the history of the light bulb one of these days, because we've really done a lot with this little device over time. Just by doing simple things like buying bulbs that last longer reduces the need to replace them. And it seems like such a simple little thing to do, but changing light bulbs can be a hazard at a workplace, certainly. And if you can avoid doing it as frequently, why not? So I found a bit of information about incandescents, which is kind of the old-fashioned light bulbs we all used to use. They last for between 3 to 5 weeks. That's generally speaking the time frame that their manufacturers will guarantee them. The newer LED lighting is good for up to 3 years. Again, there's a bit of variation on that, I would imagine, from bulb to bulb, but certainly if you can get one that lasts longer, there's some benefit there. Plus, obviously there's environmental and cost savings involved as well. So we're going to move along now and start talking a little bit about the passive controls. So again, these are, I kind of have them called engineering controls here, but these are really system controls. They involve, again, an engineering, an administrative, as well as a PPE component. So these are really more of a combination of controls. But these active controls do require that the workers do something. There's requirements there for them to kind of do a thing correctly. So again, the passive controls don't require active participation from the worker. There's an upfront cost to installing these controls, but generally speaking, once they're installed, there's very little that needs to be done with them except a little bit of maybe regular maintenance. Again, when we look at the active ones later, they're going to be a little bit of a different scenario. So there's all kinds of potential passive controls that you can use. Certainly guardrails is one that we're going to look at in a minute. But again, I wanted to kind of, again, think about some different things here. Again, getting into the slip, trip, and fall hazards. We have quite a variety of workplaces across the province that have issues with water and drainage. I would imagine most of our mining facilities, our fish plants, these types of working environments are inherently wet. There's a lot of water that's used in the work of actually processing fish or producing mined material. So it's important that the building is designed to try to keep the water away from the floors. So there's a variety of different things that you can do with regards to installing drains. And again, I just wanted to show a couple of options here. Now, I'll see the one on the right-hand side in places like a fish plant. So you're going to have different types of equipment that have the potential to overflow, or they have to be drained periodically, perhaps just at the end of the day. And it's better to drain those directly into a piping system, but where that's not an option, if they are going to be draining out into the building, to have them drain directly into a trench is the way to go. And having that type of grading that's sitting on top as the flooring allows then for water and any other kind of debris to kind of fall into that drain. At a lesser scale, the one on the left-hand side, there you can see there's a little square in the bottom left-hand corner. That's a drain. And really what this workplace has done is just added a very tiny little trench that encourages water to move towards that drain. And there's lots of options there. I've seen, some employers actually building their floors such that they angle down towards central drains, similar to things we try to do with, our highways, and even if you're, installing tile in a bathroom, there's little things you can do there. I am a big fan of the floor grading as well in porches, and I'm just going to call it the porch. So when you've got an area that leads into a workplace, often in the winter months, these places get full of water and ice and snow. Usually you'll just have kind of like a little mat or something there. But if you can add a drain, like a little trench or grading, it's a great way to kind of help take care of the slip hazards that come from dragging in snow on your boots. Again, a very common one I think most of us are familiar with is the guardrail. Now, these can be temporary or permanent, and generally speaking, they're used on flat roofs as well as unprotected edges and openings, say in a floor or what have you. I do want to just make you guys aware that there is a very strict guideline on how these are meant to be designed. The height of the top rail, things like this. This is all very covered off in engineering and in our legislation. But these are very handy on a roof, especially when you have to access it regularly, or if you're doing a big project like replacement of, say, roofing materials. There are some employers I know who have decided to simply fully guardrail their entire roof just for the little bit of maintenance that they occasionally have to do up on the roof, again, typically around their HVAC system or what have you. Bit of an expensive initial upfront cost. And again, there is some maintenance, don't get me wrong, like you can't just set these systems up and forget them. You do need to kind of check and make sure that the elements aren't causing them to corrode or anything like that. But it's a way to kind of put the control in place, and it's there, and you can kind of really don't need to do much else with it. Now, on a lesser scale, if you do have some stuff that you need to access on your roof that's within that 6 feet from the edge that we kind of use as our rule of thumb, you may be able to just simply guardrail around that specific item. So you look at, say, an older building that maybe wasn't designed in a time where we tried to kind of keep all the devices sort of towards the center. That's kind of really how things are done nowadays. You'll see all your HVAC components and things kind of in the middle of the roof. But if they are towards the edge, again, there may be a way for you to install a guardrail system so that your maintenance people can access that area without having to fully enclose the entirety of the roof. If you're using, if you do have an open hole, and Skylights is one that we've had, unfortunately, a few fatalities around in the past. Again, a guardrail is really the ideal way to deal with that hazard. I'm not a big fan of things like flagging around outdoor hazards in particular. The flagging seems to invariably get blown over or shift with the wind. So this would be, things like barriers and whatnot, but they're not really designed to stop a person. Things like caution tape and yada yada. What's really good about guardrails though is, you know, they prevent someone from accidentally stepping onto the skylight, which could damage the skylight. But in addition to that, they also protect them from falling through. And again, we've had a couple of very severe accidents over the years, and maybe I'll just highlight a couple of those. We did have an individual that fell through a skylight that was covered with a piece of plywood. This piece of plywood didn't have a label on it, and it wasn't secured. And that's really the rule of thumb with hole covers. You have to have a label on them that says hole cover or open hole or something along those lines. And they also actually need to be physically attached to whatever they're covering up. They can't be easily picked up and moved. In this particular scenario, a laborer was up on a roof and came across what they thought was just an extra piece of plywood that was just sitting up on the roof. They picked it up, and as you do sometimes when you've got like a full sheet of plywood, your field of vision is not so great, especially if you're carrying it in front of you, as this individual did. And once he had it picked up, he immediately stepped into the open hole. Another situation similar. They had these skylight openings, and they covered them with styrofoam, a piece of styrofoam just to cover the opening. And the weather changed, and they had a bit of snow overnight, and it became difficult to really identify that styrofoam was there. Plus, again, it wasn't labeled, and it wasn't able to support the weight of somebody if they were to walk on it. And unfortunately, someone came along and stood on the styrofoam, and again, there was a major event. So I think that's all I have to say about that scenario. But it's very important if you're using a hole cover that it is labeled and secured. So again, it shouldn't be able to be inadvertently moved. And if you are going to use flagging, which again is not my personal favorite here, again, primarily because we have so much wind and various other things, it's a good best practice to keep that 6 feet back from whatever the hazard is. Don't have it right at the opening or edge. Again, because flagging is not going to stop someone if, say, they're backing up. A lot of roofing work is actually done in reverse, things like torch on. You're moving backwards. You could have someone just accidentally, again, get near to that flagging and fall into the hole. So it is a good idea to use that 6 foot rule if you are going to be using something like flagging, which again is not really truly going to stop someone from falling. A couple other things to think about, again, kind of getting outside the box here. A lot of us have issues, especially with people falling during winter season, and other seasons like spring can be really bad in some areas of the province. The runoff and water can really mess up roads and walkways. I've had a couple of employers over the years that have long lasting sites, so they've been at their work site for a long period of time. And you'll notice when you have a building that's been there for quite a while that sometimes you'll start developing these little cow paths, you know, where people regularly walk, but it's not necessarily part of the design of the building. It's a shortcut situation. However, when these little cow paths kind of come to be, sometimes it's a good idea to turn them into proper walkways because they are being used, possibly by your staff or what have you. So there's a higher potential again for people to slip, trip, and fall, especially when the weather is bad. And again, I just grabbed this before and after shot just to kind of show the difference there with regards to this particular scenario. And really, they did quite improve this little pathway here. With regards to stairs, there are some, again, employers out there that due to the age of their building, their staircase might have simply been built at a time that the codes are just were not what they are today. Certainly, you know, it's better to, you know, have a perfectly built, new design, engineered stairwell. Sure, but obviously there's cost and practical kind of things to think about there. But there are ways to actually improve an existing set of stairs to make them safer. Certainly any staircase should have handrails, but in addition to things like that, you can add new anti-grip or sorry, not anti-grip, anti-slip coatings to your stairs to help reduce people slipping. You can also add high-vis to the edges, especially important if you've got any irregular stairs, so stairs that are not really built to the current code. These are, again, little minor things you can do to kind of reduce slip, trips, and falls. I've had a couple of employers, do some thorough looks at the types of fall-related accidents that they've had, where they might have flagged a particular piece of equipment or a particular set of stairs that is seems to be an issue for them. And again, looking at the cost of claims and things like that, it can be pretty easy to justify something as simple as some high-vis material and some anti-slip grips, a lot of which, again, that are basically stickers that you would just apply right to your steps. I also usually like to talk a little bit about falling objects when I talk about slips, trips, and falls and working at height. A little bit of a side issue, but generally speaking, when you have people, especially working at height, there is a potential for people working down below to be injured by their activities. So it is important to make sure that workers manage their materials, as well as any other kinds of tools and things that they're using when they're at height, so that they don't accidentally get dropped, or maybe the wind takes them and blows them down on people down below. So there's lots of different options out there as far as controls that you can use for this, but really the two main ones that I see are things like tool lanyards, or these little kind of often spring style kind of tethers that you can attach to your tools, so that if you do drop them, they can't fall down below. You can also use things like netting, debris netting, to try to improve a work area at height to reduce the potential for things to fall. And it's not uncommon to see debris netting on very high scaffolds where you have a lot of people working at different levels, and also in our above our public streets. If you have a walkway, say for example outside, an exterior walkway that has a lot of traffic, pedestrian traffic, sometimes they'll build a scaffold above to kind of protect people down below from accidental materials falling or dropping on them. And when you are using any type of lift or device, it's also not a bad idea to secure the area by, setting up a work area using flagging or caution tape or something like that outside, certainly a little ways back from what you're doing, again, to protect people in the event that something is to fall. And I always kind of use that 6-foot rule in these scenarios to kind of cover off, where I would locate my flagging, but it certainly would depend to a certain extent on how much reach that lift, that AWP has. So how far, certainly the swing radius really on that arm, the articulation. So moving into fall restraint, this is the first type of active control that we're going to talk about. A little bit different from fall arrest in that if fall restraint systems are set up properly, the worker should not fall. So they look similar, fall restraint and fall arrest. They often involve the same equipment, but the difference really between restraint and arrest is that in a restraint system, the worker should never be in a position to fall, whereas with a fall arrest system, there's a potential for them to fall, and the system needs to be strong enough to arrest that fall and kind of bring them to a safer stop. So these are a very handy system to use when you're working within that 6 feet from an unprotected edge. So I'm up on a flat roof. It doesn't have a guardrail. I know I'm going to have to work within 6 feet of the edge, but I don't really need to work beyond that. I may very well be able to use a fall restraint system, again, that prevents me from being able to reach that edge and actually fall over it. Now, these systems obviously need to be set up very stringently. There can't be any wiggle room as far as workers getting a little bit of extra length in the line. It has to be set up such that they cannot fall over that edge. So there's, again, planning involved here as far as setting these up, and it's important that the right pieces of equipment are used that don't have extra give that can make the line longer. So we think about stuff like self-retracting lanyards. They wouldn't be used in this particular scenario unless you base it on the fully extended length of that SRL. So again, just to kind of give you an example, with a fall restraint system, if you're at the edge, you've got no room. You cannot go any further. Your line is tight. There is no slack. Where with a fall arrest system, you're imagining that the person needs to be able to access the edge. They're going to be in a situation then where they have the potential to fall. So there's going to be a little bit more, a slightly different design going on in their system. So I just wanted to give a couple examples of fall restraint. So I've got a picture on the left-hand side there. That's a little close to the edge for me, but at the same time, you know, I don't know exactly the way that that's designed, but generally speaking, again, you don't want to be able to reach and fall over that edge. And so we can imagine that person has an anchor up and to the right of them that they're attached to. The middle one there is a flat roof, or it looks like it's got a bit of a pitch to it. And basically what they've done is they've installed this horizontal line that runs along that 6 foot 6 foot edge where you would have to tie off. So you can kind of be in the safe area. Outside that 6 foot edge, you can clip on, and then you can step over into the area that you need to access. And again, it's just enough length for them to access, but not be able to reach beyond or fall. And then the pole climbing systems really are a type of fall restraint. They're kind of set up so that you can't fall more than 2 feet. That's the restraint aspect on pole climbing gear. So if you accidentally slip or fall, you'll just fall about 2 feet, and then you should be able to right yourself. With a restraint system, you do have a full body harness, which is the contraption that the person is wearing. There is some kind of lanyard or lifeline that then attaches that harness to an anchor point or a horizontal line, which is really what we've got going on here in this image, which is a little bit blurry. Again, the most important element of this really is the lifeline or lanyard. It needs to be a fixed length. That is the critical piece here. Again, it should be set up such that the worker cannot go beyond the edge, because then we're getting into a fall arrest situation. So certainly workers need to be able to reach what they're doing. And that's kind of one of the practical aspects to this. You know, when you're trying to keep someone's lifeline or lanyard as short as humanly possible, sometimes we go too far and we realize that, geez, the worker can't even do their work now. They can't reach what they need to be able to get to. So again, there's some practical components. I do want to highlight that there's no specific distance in our legislation that it says you know, this is restraint, this is arrest. But the general kind of rule is, again, if you have the potential to go beyond the edge or opening, then you need arrest. I always like to think of whether or not the worker is going to have to reach to get to whatever it is they're working on. And if they really have to overextend in the restraint system to try to do their work, then you may be in a situation where you really need fall arrest instead of restraint. So as I kind of talked about a little bit earlier, this is really a system, the fall restraint system. That's what we're talking about here in this section. Wherever you have one of these systems, whether it's restraint or arrest, you do need to do some planning to make sure that the system in particular is set up correctly. A poorly designed system can result in workers making changes to the system because they want to be able to finish their work. And these changes could potentially put them at risk. So for example, if you put someone in an SRL, like I mentioned earlier, and they have the potential to go further than, say, the 4 feet that was allowed in the plan, it's possible that they may be tempted to do that. Often as well with restraint systems, supervision is really important to make sure that workers are following rules and guidelines that are in place within this plan. So just something to think about. So I've got a little picture here. I like to talk about this picture. I think I talked about this one in another presentation I did a while ago. This is really kind of, to me, a good example of a fall restraint setup. So we've got an individual, let's just imagine they're working on the 4th story of a new building. Maybe it's a parking garage or something that's being installed. So you can see that they've got some flagging that's going around the work area, and that's kind of set up at about 6 feet from all the unprotected edges. So again, like if you look at the guardrail, it's about 6 feet over. They've also got some signage there next to their flagging to alert workers to why that flagging is there. That is a really important thing to do. I gotta say, as a safety person, I got a bit of a pet peeve with people putting up caution tape and danger tape with no information whatsoever as to what that the person should be cautious or be concerned about. So it's important to have signage that it's at least states what the hazard is, and if there's somebody that has to be contacted to access that area or what have you. So we've got lots of good anchor points potentially in this work area. We've got these big massive concrete columns that are kind of perfect for tying off to. In this particular scenario, the worker is assisting a crane to lift materials up onto this floor. So there's a crane operation kind of going on outside the picture on the right-hand side. This worker's job is to kind of grab the tag line as the crane approaches with the load and kind of bring it in, and then kind of have it sit there next to them in their kind of lay down area, I'll call it. Again, assuming the system is set up correctly, this worker should not have enough give in that system so that they can step over that edge. That is the critical piece here. So we'll carry on. The next system we're going to look at is fall arrest. So this is very similar to fall restraint. Again, the big difference is that in a fall arrest system, the system is meant to be set up so that if you do fall, it will bring you to a safer stop. And I always say safer stop because I've talked to quite a few workers over the years who've fallen in their arrest and been suspended. And often there are some minor injuries that you'll incur, like things like bruising. Sometimes the injuries can be more severe. And obviously with prolonged suspension, that you get into some additional risks with things like toxic shock and different things like that, that can be potentially medically serious, and where you'd need to, send the person to hospital. So when we think about the arrest system, really what it does is it kind of takes all the forces that you create as your weight is falling, and it helps distribute those forces to some of the larger areas of the body. So there's kind of like these 6 points that they talk about around the thighs, the hips, the upper back and shoulders, rather than having all the forces go on the abdomen, which is kind of how we used to do it. We used to wear these things called body belts, where you just kind of wrap a rope around your waist. And these are, well, with use, we found out fairly quickly that these types of systems were pretty dangerous, that often when people fell in these, they would have internal damage to their abdomen. They might have major back injuries. And in fact, I was always told this, I don't know, maybe it's a bit of a rumor, I suppose, when I first started learning about fall protection equipment years ago in my career, that some of the first fall arrest that we used, kind of humanity used, was really during the Industrial Revolution in Europe. We were starting to burn coal and things like that, and shop owners were starting to notice that there was a lot of soot and stuff building up on their windows. So they would actually hire prisons to come in and use their prisoners to clean their windows. And that's exactly what they used to do, is tie a rope around the waist, and they'd get up and do their work and what have you. And basically what these groups found was that it was worse for business to have someone hanging off your roof, potentially succumb to being killed by these forces of the fall than it was to simply have a dirty, sooty window. So we've come a long way. Certainly body belts should never be used in a fall arrest system. They're prohibited. You could potentially use them in a fall restraint scenario, again, because the individual should never fall. However, I'm kind of the opinion that you're better off having the full body harness. I mean, why go out and get a body belt when you can just use the harness, because you'll probably need it for something else in the future. So a fall arrest system includes the same stuff as a fall restraint system. We've got our anchor point, we've got our lanyard or our lifeline connecting that anchor to our harness. But the kicker here with this is that we're not just tethering a worker to this, you know, and preventing them from being able to kind of reach beyond. This system needs to be able to deal with the forces of a fall, which can be quite a lot. So I do like to just highlight that the whole system needs to be equally strong. If there's any part of the system that fails, it could be what you're tied off to, it could be the thing they use to tie off the anchor point itself, it could be your lanyard or lifeline, it could be your harness. Any part of that, if it doesn't work, the whole system really is going to fail. So again, it's very important that there's very thorough planning involved with setting up these fall arrest systems. Now, before we go into any more detail, I've got to have my next micro break because we're kind of at the time there now. So again, if nothing else, just get up out of your seat and move around a little bit. That's really kind of what we're trying to get at here with these little micro breaks. Again, I'm going to take you through a quick little stretch for the upper back and shoulders. So I'm going to get you to reach your right hand across the left side of your body, kind of support your arm at the elbow with your other hand. And we're just trying to kind of stretch out the upper shoulder joint. It is a good idea, again, to keep your head kind of neutral and looking forward with this exercise. You might hear a little pop because I have a tendency to pop my shoulder when I'm doing this, but it shouldn't be painful. You're really, again, just trying to get a little bit of a minor stretch going. And then we're just going to relax that arm, give it a little shake. We're going to do the same thing with the other arm. So we're going to reach left arm across the right hand side of our body, support it at the elbow, and again, try to get a little bit of a stretch going in that shoulder joint. Hold it for a few seconds. Then we'll just do a couple more shoulder rolls just to kind of loosen everything up. A little bit of a wiggle, and we're good to go. Okay, so continuing on with our discussion about fall arrest, there's really a lot more involved with planning with a fall arrest system versus a restraint system. One thing in particular to consider is energy absorbers. So these are sometimes called shock absorbers or shock packs. These are required wherever there's a potential free fall of more than 4 feet. Now, I'm not going to get into all the detail of exactly what I mean by free fall, but generally speaking, if you are in a situation where you're going to be falling, you need an energy absorber included in your system. However, if you're using your system for restraint purposes, these would not be required because you're not going to fall. Again, if the system is set up correctly, there should be no potential for your worker to fall. They effectively are on a tether, and that's the purpose of it, is just to prevent them from moving. So these are an important system to consider if you need fall arrest. I also just wanted to highlight that we do have a new CSA standard out in recent years around the classes of energy absorbers. We used to have E4, E6. Now we have this new class called Y. So again, just a little bit of food for thought for you all if this is news to you. These new Y class absorbers no longer have specific weight requirements that were in place for the E4 and the E6. Wherever you use a fall arrest system, again, you need to have a fall protection plan. And what you need in this plan is a little bit more thorough than what you would need for a restraint system. In addition to basic job information, roles and responsibilities, hazards, as well as whatever equipment you're going to use, so the system itself, you also need to have a plan in place to rescue someone if they fall and in their arrest system and they're suspended. So again, in a restraint system, there should be no falling. So we don't need energy absorbers. We don't really need a rescue plan to deal with someone who's suspended, but this stuff is necessary for an arrest system. And part of the figuring out what equipment you're going to use, which is that second last bullet there, also involves doing some calculations. So whenever you're using fall arrest, there's some calculations that you have to perform, and they have to be performed in accordance with the CSA. Sometimes I do come across employers that are using calculations that are supplied by the particular manufacturer that they use. I'm not saying that those shouldn't be taken into consideration, but the way our legislation is designed, the CSA standard, specifically that one I've got listed there on the design of fall protection systems, that really is the one that needs to be the priority. So these calculations are designed to make sure that the system has enough length to prevent the person from bottoming out or hitting the ground. And I do hate to say this, but I've had a couple of employers over the years say that as long as you prevent the person's head from hitting the ground, that you've done it. And I'd just like to say here that that simply is not the case. These systems are meant to be set up so the person does not hit the ground with any part of themselves, and there really should be a bit of a safety factor, a bit of extra room for which they would dangle. And again, that's where this element for rescue comes into play, because you've got someone who's been suspended. They're dangling in the air, and now they need a means to get down from there, you know, as soon as possible. Again, because there are some circulatory illnesses that can come about when you're left in suspension for a long period of time. So methods to reduce the potential force on a person if they were to fall. These things should be considered. Again, we've got a situation where we're saying we know there's a hazard and we know that there's a potential someone may fall because of the nature of the work that they're doing. So we want to do everything in our power to ensure that the forces that they experience if they do fall and are suspended in their equipment are as low as possible. So some general tips here to consider is reducing the distance between where they're working and the next safe level. So reduce that in some fashion. Trying to keep the anchor point at shoulder height or above. This particularly has an impact on that free fall distance that we kind of touched on earlier. Keeping the lanyard or lifeline as short as possible. Again, not allowing for this massive, maybe, I think the maximum lifeline you can get is something like 300 feet. You know, when would you need that, really? Unless you're, I don't know, climbing a tower or something. Whether or not you need an energy absorber. That's an important piece. And then all the things that would also affect your weight if you were to fall. So what types of stuff you're carrying with you, and whether you truly need all that stuff. Again, the weight kind of is an impact on the amount of force that's generated when you come to that safer stop. Generally speaking, your system should also be set up to avoid swing fall as much as possible. The anchor point should be located directly above the worker, so that there's no potential for them to walk off to the side and then fall and then potentially swing. The calculations that are required for swing fall are very complex in that CSA standard. So they really have made it such that it's just easier to avoid this if at all possible. The horizontal lifeline is really one of the main kind of options I can think of, you know, when you're in a situation where you do have to move away from your anchor point horizontally. Those systems, you know, as you move, your anchor point comes with you. You're basically pulling your anchor along the line as you go, so that your anchor, you can keep it close to your body so that if you do fall, you can avoid this swing scenario. We talked again a little bit earlier about the importance of having that plan in place to rescue someone if they've been suspended. So again, that is required if you're using fall arrest, and these types of rescue plans really need to be timely. It's very important that that person is not suspended for any longer than they have to. I've seen a lot of different options for rescue plans over the years. I just wanted to kind of highlight one or two. when working out of a lift, I've often seen that the rescue plan is to have a second lift kind of go underneath the individual who's suspended and kind of bring them to the ground. Again, due to the timing and how important time is really when someone is suspended, that lift, that second lift, should be ready to go. The driver of that lift should be prepared. It's no good to have that second lift you know, half a kilometer across your work area, or to have the driver gone to lunch, or maybe there's no fuel in that lift, or you don't know where the key is. All these things, you know, need to be ready to roll at the moment somebody falls. Again, the time is very critical again for these suspension related injuries. And again, there's other options there for rescue. You might use rope access if you've got people who are trained to do that type of work. There's different kind of things you can do, but it's important that the plan is ready to roll. It's a good idea to review it right before you get ready to start the job, so that the people that are working there can think about it, and if there's any issues with the practicality of making this plan work, you can kind of figure it out then before you actually start doing the work. So finally, I've got our lowly administrative controls, which again are right at the end here. So these are controls purely pure administrative controls. They don't involve a PPE component or any other kind of component in place here. And really, there's just one or two kind of options for administrative controls around slips, trips, and falls, and including falls at height. But generally speaking, it's a work practice or some type of procedure that you're using to reduce your potential to fall. So the examples really are warning systems, which we've talked a little bit about already. So these are your flagging, your caution tapes, and what have you. Again, it's important that they're set up at a distance because they're not meant really to catch a person like, say, a guardrail would. We've also got this concept of safety monitors. Again, very much your last option as far as practicality goes, and I'll talk a little bit more about the safety monitors in a moment. So these are best used when in combination with other systems, sure, but again, these controls are at the bottom of our hierarchy, so they really are the least effective. And one of the reasons for that is sometimes because they require workers to do things, they get overlooked. Something comes up and the workers do things a little bit of a different way. So I got a couple of examples here. So again, the barrier, the flagging, the tape, what have you. Again, very important that there's signage combined with that and that you're using the right kind of tape, whether it truly is danger tape or caution tape. So this could be, again, anything from a sign on a door to a complete barricade around in a work area that could be quite substantial. Again, I would just encourage that if you are using these systems, that you set them back a ways from any actual hazards. I have come across some tape over the years that's really been used inappropriately. The last one I saw, I think, was in an industrial site, and they actually had a section of their floor, which was a graded floor with kind of handrails on it, that had been removed, and they just kind of put the danger tape right at the edge of like where this floor was just gone. And certainly, in some situations, you could have dusts and steams that are created from industrial work. You could have a power outage. You could have somebody who's moving backwards for some reason. Maybe they're pulling something along or what have you. But these barriers, again, they're not going to stop someone from falling into a hole. In those types of scenarios, you really need to use something suitable that is, again, secured properly and what have you. And I always kind of think of this example that I heard about years ago from a friend of mine, actually, who was doing a job around an open pool that was empty. So this was like a swimming pool. There was no water in it, and they were kind of refinishing the floor, the tile, and whatnot, kind of making it new again. And their employer set up a series of flags around the edge of the pool to alert workers to the fact that they could fall into the pool, because again, you've got this open hole because there's no water in the pool. Now, it just so happens that because they were doing tile work, they didn't want to secure this guardrail that they had purchased to go around the pool or rented or what have you. So they just kind of had it laid there. And then they had a safety meeting, as you do, like occasionally, especially in the construction industry when you're doing a lot of different things on in kind of one day than the next. They had I think they had their the person who was leading the meeting was actually standing in the pool, again, the empty pool, and then all the staff were kind of around the edge of the pool, kind of listening to the discussion. And they had a worker actually lean on that guardrail that was, again, set right up on the edge, but it wasn't actually secured. It wasn't bolted to the ground, again, because the tile and what have you. And this individual actually fell into the deep end of the pool in the middle of the safety meeting. And again, there was a bit of a kerfuffle there as far as, what that guardrail was supposed to do. Again, a guardrail has to be set up to prevent a person from leaning and pushing or falling on it. Like, short of climbing it or, overreaching, getting through the edges and whatnot, that guardrail should be able to prevent someone from falling into that area. Really, they were using a guardrail as a warning system, which is confusing, certainly. And because, in most cases, when you see a guardrail, you would expect it to be able to handle you leaning on it. They should have had that system, if it really truly was just to warn, back a distance from the edge to make sure that, again, if someone did lean on it, they wouldn't be able to fall. And now my final my final administrative control is the safety monitoring system. Again, this is the absolute kind of last thing you should ever kind of go with. But there is some potential to use a person to warn other people as they approach a fall hazard. So generally speaking, this person is assigned to this job, and that is it. Kind of similar to someone who's doing fire watch or who's, say, a confined space attendant. They have no other job other than to monitor where the other workers are and make sure that they're not handy to that fall hazard. So you might use this in a situation like a roof if you're replacing it, because it may not be possible to set up things like barriers because you're physically removing the structure of the roof as you go. So it's an option. It's, again, should be the last option because it's not particularly, it requires too much worker participation. But again, you've really got this competent person whose job it is to basically let people know that they're approaching the 6-foot edge of that roof. So we were unable to put a line down because of the nature of the job we're doing. So we're using a person in its place. So this person is replacing flagging or barriers. They're not replacing a guardrail system. So just to summarize, and I do want to just remind you guys, now that we're at the summary, that, I'm going to start looking for questions. So feel free to put any questions you have now into the chat window. But I will kind of just cover up my last few slides here while you're doing that. So it's really important for employers to try to reduce their fall hazards. Slip, trips, and falls are still a major issue here in the province. Whether they're at height or otherwise, they are kind of across the board in every industry: mining, manufacturing, construction, and also in, healthcare and general offices, retail, all that kind of good stuff. So it's a good idea to, look at your accident investigations regularly, look at the types of hazards you're having, try to, or accidents you're having, try to kind of target things that you can fix, things that are reasonable, practical for you to fix to reduce your risks. And when you're doing that, you want to consider this hierarchy of controls to make sure that you're using the safest options first before you move on to something else. So that's the idea here, is to, at least explore the options of elimination before you move straight to fall arrest. I've been in some workplaces where their rule is tie off at 10 feet. Again, it could be 6 feet or 4 feet even if there's a best practice in place. But tying off at 10 feet, so we're assuming you're using an arrest type system, is not always practical in its own right, because you need that space, that clearance between the worker where they're working and the ground in order to make sure that system is effective. Again, I mentioned the 4-foot rule that one employer I know at least used for a time. So their rule was to tie off at 4 feet. So if they had to get up and say, I don't know, change the light on say a big piece of heavy equipment, they would have to get a scaffold realistically, because tying off was not going to work. The clearance was not sufficient for that system to be appropriate. But I see that a lot. I see people tying off at heights where it makes no sense to tie off, because with the length of their system and what have you, they're going to hit the ground. So again, you want to try to explore the safer kind of options first. So I do want to thank you guys for attending this presentation. Again, you know, very, very much fall protection is a big piece of what we do here over at Workplace NL. You know, again, we're going to be trying to roll out this fall protection month kind of on an annual basis from here, and we want to encourage you guys, certainly if you have these types of hazards, to chime in to our webinars, you know, if you have time in your schedules. We do also appreciate your feedback, and once you log out of this presentation, there will be a little email that comes to you that asks you to complete our evaluation form. In particular, any topics that you would like us to present in future years, that's always kind of a really important piece to that. I want to again just alert you guys to some upcoming events that we have. So these are all webinars. We've got a couple of other ones this November to check out, unrelated to falls. We've got an interesting one around MSIs and evaluating the risk. We've got a good presentation on hand injuries on the 25th that I might actually chime into that one myself. Another very common type of injury in many industries. I'm actually doing a presentation on the 1st of December around the beauty industry. So that's like, you know, the hairdressers and the estheticians and all that kind of crowd, the nail salons, where we're going to be talking about some of the health hazards that they're exposed to. And again, we've got our fall protection month. So there's some other additional presentations related to that. I also want to just take this moment to plug the OHS app that we put out last year. This is going to actually be updated now shortly. So currently it has 10 different topics on, again, some specific health and safety kind of elements that we thought were really important to get out in the first kind of phase of this project. But this app is designed more or less to put some of our legislation in the layman's terms, but it's also helps to link you up to some vetted resources and things of that nature. And it does have access to the legislation as well if you want to just read your ledge verbatim. This is the method to go about signing up for any of our future webinars. If you're not familiar, there's an events page that you can get to. And of course, we've got our contact information as well if you do need to reach out to any of our regional offices. So again, I'm very happy to have you all here today. I want to encourage you all to, again, check out the rest of our webinars for the year. And thank you so much. And hopefully we'll see you all again when I do another webinar.